We're going to look at finding what is known as a critical value or a critical number. Those are synonyms for each other. So in terms of a definition, critical numbers or critical values are the x-coordinates of all the points where f prime of x is either equal to 0 or f prime of x does not exist. So as a refresher, recall if the derivative is equal to 0, then we're talking about having a graph that looks something like this, where when I draw a tangent line, the tangent line would end up being horizontal, so then at that point at the top, that is where f prime is equal to 0. If the derivative does not exist, it is d and e, then I have one of two things happen. It's either a sharp turn, so that could be like an absolute value. So in this case, at the vertex here, f prime does not exist. Or it could be known as a vertical tangent line, where I have a function that comes in, goes up, and then keeps going. And if I was to draw the tangent line there, the tangent line in the middle here at the origin is actually going to be vertical, and the slope of any vertical line is undefined, so f prime does not exist there. That would be something like x to the 1/3 or something like that. And of course, if a function is not continuous, it is not differentiable. So anything with a hole, a vertical asymptote, or a jump discontinuity is not differentiable at that point. So our first example says, find the critical numbers for f of x is equal to x cubed minus 12x squared minus 60x plus 36. So first step, by definition, the critical numbers are where either f prime is equal to 0 or f prime does not exist. So the first thing I need to do is find f prime. Now this is a really easy one to begin with. This is just simple power rule here. I end up with 3x squared minus 24x minus 60 is equal to f prime of x. Now that's just a simple quadratic, which could never be undefined in terms of f prime of x, so I do not have to worry about f prime being d and e, being something that does not exist. I just need to figure out where is f prime equal to 0. So I'm going to set that equal to 0, and this is where our algebra comes into play. I can factor out the common factor of 3, leaving me with x squared minus 8x minus 20 is equal to 0. And then that factors further. I can factor that into x minus 10 times x plus 2. Now I could divide the 3 over, so really the 3 is not going to make a difference here for the x values. So when I solve this for x would equal 10 and negative 2. Those are what we refer to as our critical values or critical numbers. So here's another example. Find any critical numbers for f of x is equal to the rational function 2x squared over x minus 4. Now, because I have a rational function and I'm trying to differentiate, that means I have to use quotient rule. So f prime of x would equal the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And since my goal is to figure out where f prime of x is either equal to 0 or does not exist, that means I'm going to go ahead and simplify the numerator. That way I can figure out where is this fraction going to equal 0 and where would this fraction be undefined. So if I go ahead and distribute that 4x, I end up with 4x squared minus 16x minus 2x squared over the bottom squared. We're not going to FOIL the denominator because my goal is to just eventually set that equal to 0 and solve for x. So that'll be much easier to do while it's in the factored form. And this, of course, simplifies to 2x squared minus 16x over the x minus 4 squared. Okay, now, if I'm trying to find the critical numbers come from where this derivative is either equal to 0 or does not exist. Because I have a fraction is equal to 0 when my numerator is equal to 0. So if I want to find the piece where f prime is equal to 0, in order to do that, I'm going to set the numerator 2x squared minus 16x equal to 0 and solve for x. The other half of finding critical values is where the derivative does not exist. Well, because my derivative is a fraction is undefined when my denominator is equal to 0. So the second half of this problem, I'm going to have to figure out where f prime does not exist by setting the denominator equal to 0 and solving that for x. So with the first part, f prime is equal to 0, I can factor out a 2x, leaving me with x minus 8, and that'll end up with x is equal to 0 and positive 8. Solving the second half, where f prime is d and e, I'm going to have x is equal to 4. So I end up with 3 different answers here, and all 3 are going to be my final answer for the critical values. So I have x is equal to 0, 4, and 8 are all critical values, or also called critical numbers, for this original function f of x. Our last example is perhaps the most difficult example, and that is because we are given a rational exponent here. So again, I want to find the critical values, but this time my function is f of x is equal to 2x minus 3x to the 2/3. So again, I'm going to start by taking the derivative. So f prime of x would equal 2 minus 2x to the negative 1/3. And then I need to solve this for x. Now, most people would probably just go ahead and set that equal to 0 and solve for x. However, that would actually give you only half the answers, and I'll show you that momentarily. So what we need to do is go ahead and rewrite that negative exponent so that it's in the denominator of the fraction. So I have 2 minus 2 over x to the 1/3. It's very tempting to set that equal to 0 and solve for x. However, what I really need to do is get a common denominator here and then add these two together to combine them into one fraction. So my common denominator is x to the 1/3. So what I'm really going to do is go back over here, erase that. I'm going to multiply by my common denominator of x to the 1/3 over x to the 1/3. And so this allows me to have 2x to the 1/3 minus 2 all over my common denominator of x to the 1/3. That's my f prime of x. Now keep in mind, by definition of a critical value, that is where the derivative is either equal to 0 or does not exist. Now I have a fraction, so just like the last problem, I'm going to have to set the top equal to 0 and the bottom equal to 0. So this first part, if I set the top equal to 0, I have 2x to the 1/3 minus 2 is equal to 0. That gives me 2x to the 1/3 is equal to 2. Divide by 2, now I have x to the 1/3 is equal to 1. So then x is equal to 1. But we also have to solve the bottom part equal to 0. And so I'm going to take my denominator now, and I'm going to solve that part over here. So x to the 1/3, I'm setting that part equal to 0, and that gives me x is equal to 0. So I end up with two different critical values. I end up with x is equal to 0 and x is equal to 1, and those are all my critical values for the original f of x. Now let me show you what would have happened if I had gone back to this step right here and just set it equal to 0 and did not get a common denominator and combine them into one fraction. So I'm going to move all of this over a little bit. So let's go back to this step right here. If I took that 2 minus 2 over x to the 1/3 and just set that equal to 0, which is what a lot of people are tempted to do, then I would move that fraction to the other side. Cross multiplication would give me 2x to the 1/3 is equal to 2, and I end up with x is equal to 1, which is what I ended up with over here. However, that eliminates this whole portion where I end up with x is equal to 0, and so I would only end up with half the correct answers. That is why you have to get your common denominator, combine them into one fraction first, then I could set the top equal to 0 and the bottom equal to 0 to figure out where is f prime equal 0 and where is f prime undefined, or d and e. And so what I did over here on the side is not something you would want to do, because you would lose half of your answers.